I'm going to solve a mixture of relation and function problems, right? So let's get started. So question number 1. F and G are functions defined as follows. F of x is equal to 7x plus 4 and g of x is equal to 1 over 2x. Evaluate g of 3, right? So g of 3 here means that we are going to substitute the value 3 into the function g of x. So in other words, where we see x, we are going to replace it with 3. So therefore, g of 3 is going to equal to 1 over 2 times 3. So remember, instead of writing back x, replace x with 3. So all we need to do is to simplify this and we're finished. So it's going to be 1. And remember that the bracket implies multiplication. So this is 2 times 3, and that's going to give us 6. And we're finished. For part B, we're asked to find f of negative 2. What this is saying, substitute negative 2 into the function f of x. So we know that f of negative 2 is going to equal to 7 times x. But instead of writing by x, we must replace x with negative 2 and put back our plus 4. All we need to do is to simplify this and we're finished. So 7 times negative 2, that's going to give us negative 14 plus 4, and negative 14 plus 4, that is going to give us a negative 10. And we're finished. Now to part C, we're asked to find f inverse of 11. But before we can find f inverse of 11, we need to find f inverse of x. So let's go ahead and find that. We know that f of x is actually equal to 7x plus 4. Now if we want to find the inverse of this function, we should let f of x equal y. So if we write the function in terms of y, what we will have is y is going to equal to 7x plus 4. Then at this stage, we must interchange x and y. So where we see y, we're going to write x, and where we see x, we're going to write y. So we would have x is equal to 7y plus 4. At this stage, we are going to transpose to make y the subject of the formula. So in other words, here we have x equaling 7y plus 4. So what we want to do is to manipulate this and get y equal to something, right? So the first thing we need to get rid of is this plus 4. How can we get rid of the plus 4? We can get rid of plus 4 by subtracting 4 from both sides. So we're going to subtract 4 from this side. And we're also going to subtract 4 from this side. So on the left, what we have is x minus 4 is equal to 7y. Now we want y by itself. We're multiplying by 7. Do the opposite of multiplying by 7, which is to divide by 7. But we have to divide both sides by 7. And here, 7 will cancel out 7. So what we left back with on the right hand side is y. And on the left, we have x minus 4 over 7. But we must remember we're trying to find the inverse of f of x. So we must replace y with f inverse of x is equal to x minus 4 over 7. So we now know that f inverse of x is equal to x minus 4 over 7. Now we can go ahead and find f inverse of 11. Because what this means is that we must substitute 11 in the function f inverse of x. So therefore, f inverse of 11 is going to equal to, instead of writing back x, we're going to replace x with 11. So it's going to be 11 minus 4, all of that over 7. All we need to do is to simplify our numerator and we're finished. So 11 minus 4, that is going to give us 7 over 7. And 7 divided by 7 is going to equal to 1. So therefore, we can write a final statement to say, therefore, f inverse of 11 is equal to 1. Alright? And we're finished. Question number 2. Given that g of x is equal to 2x plus 1 all over 5, and f of x is equal to x plus 4, calculate the value of g of negative 2. What this means, substitute negative 2 into the function g of x. So therefore, we know that g of negative 2 is going to equal to 2. Instead of writing back x, we must replace it with negative 2. So we're going to introduce a bracket and put negative 2, back our plus sign, back our 1, and all of this should be placed over 5. All we need to do here is to simplify, and we're finished. So 2 times negative 2, that's going to give us a negative 4, plus our 1, and all of this should be placed over 5. And then negative 4 plus 1, that's going to leave us with a negative 3, and this should be placed over 5. So therefore, g of negative 2 is equal to negative 3 over 5. Now for part B of the question, write an expression for g of f of x in its simplest form. So what this means, we are putting the function, right? We are putting the function f of x into the function g. So we are putting the function f of x into the function g. So we can write back this statement as g of f of x, but instead of writing f of x, we are going to write x plus 4, because f of x is equal to that. So it's going to be g of x plus 4. So this is going to equal to 2 times x, but instead of putting back x, we're going to replace x with x plus 4. So it's going to be 2 times x plus 4 in bracket, put back our plus 1 all of this should be placed over the denominator of 5. At this stage, in order to remove the bracket, we're going to apply the distributive law, which states that whatever is directly outside of the bracket, you must take it to multiply each term inside of the bracket. So 2 times x, that's going to give us 2x. And 2 times positive 4, that's going to give us a positive 8. And we write back our plus 1. And all of this should be placed over 5. All we need to do now is to simplify our numerator and we're finished. So it's going to be 2x. And 8 plus 1, that's going to give us plus 9. And all of this should be placed over 5. So therefore, g of f of x is equal to 2x plus 9 over 5. Now to part C, calculate part C of number 2, calculate the value of g of f of negative 2. We know what g of x is, so we can recall that. So we can recall that g of f of x is equal to 2x plus 9 all over 5. Now we can now go ahead and find g of f of negative 2 by just substituting negative 2 for x into the function g of f of x. So we know, we can say therefore g of f of negative 2 is going to equal to 2 times x, but instead of writing back x, replace that with negative 2, so it's going to be 2 times negative 2 plus 9, all of that over 5. What we need to do is to simplify and we're finished. So 2 times negative 2, that's going to give us a negative 4 plus 9 all over 5. And negative 4 plus 5, that's going to give us positive 5, and positive 5 divided by 5, that's going to give us 1. So therefore, g of f of negative 2 is equal to 1. Now to part D of the question, we are asked to find g inverse of x, right? So what we're going to do, step 1 is to let f of x equal y. So we're going to write this function in terms of y. So we know that y is going to equal to 2x plus 1 all over 5, right? At this stage, we're going to interchange x and y. So it's going to be x equal to y plus 5, 2y plus 1, sorry, all over 5. At this stage, we are going to transpose for y, meaning that we want y to equal to something. So we need to get rid of the denominator of 5 here. So what we can do is to multiply both sides by 5. On the left hand side, 5 times x gives us 5x. On the right, 5 will cancel out 5, so what we're left back with is just the numerator, which is 2y plus 1. Here we need to get rid of this plus 1. We're going to do the opposite of adding 1, which is to subtract 1. But if we subtract 1 from the right hand side, we have to subtract 1 from the left hand side as well. So here, clearly you can see plus 1 minus 1. What I'm going to left back with on the right is just 2y. And on the left, I still have 5x minus 1. Now I need to get rid of this 2. This 2 is multiplying the y. I need to do the opposite of multiplying by 2, which is to divide by 2. But if I divide the right hand side by 2, I need to divide the left hand side by 2 as well. So remember, 2 will cancel out 2 here. So on the right, left back with y. And on the left, I just write back what I have, which is just 5x minus 1 all over 2. At this stage, we must remember what we're finding is g inverse of x. So we replace this y with g inverse of x. So here, I'm going to write it here. Therefore, g inverse of x is going to equal to 5x minus 1 all over 2. And we're finished. Question number 3, part A. Given f of x maps onto 3x plus 7 and g of x maps onto 4x over 5 minus 9, calculate the value of f of g of 10. Now, before we can determine f of g of 10, we need to determine the function, the composite function, f of g of x. Now, remember that f of g of x means we are substituting g of x into the function f. So we're going to substitute 4x over 5 minus 9 into this function 3x plus 7. So in other words, we could rewrite this as f of 4x over 5 minus 9, right? So this is going to equal the function f, which is 3, and instead of putting back x, we must remember, we must replace it with 4x over 5 minus 9, close our bracket, and we put back our plus 7. So now we know that f of g of x is actually equal to 3, open bracket, 4x over 5 minus 9, close bracket, plus 7. Now we can go ahead and determine the value of f of g of 10. So what this is saying, where we see x in this function, we should replace it with 10. So therefore, f of g of 10 is going to equal to 3 open bracket 4. Instead of putting back x, I'm going to replace it with 10. So it's going to be 4 times 10 all over 5 minus 9 close bracket plus 7. But here, you have to remember your order of operation, right? So you have to solve what's inside of the bracket first. So what we're going to have here, note 5 can go into 10, right? So 5 into 5 goes 1, and 5 into 10 goes 2. So what we have here is basically 4 times 2. So I'm going to put back my 3 here, open my bracket, and 4 times 2, that is just 8. Put back my minus 9, close my bracket, and put back my plus 7. So 8 minus 9, that is going to give me minus 1. So what I have here is 3 times a negative 1 plus 7. And I'm going to continue over on this side. So 3 times negative 1, that's going to give me a negative 3 plus 7. And a negative 3 plus 7, that's going to give me a positive 4. So therefore, you can write a final statement to say, therefore, f of g of 10 is equal to 4. We are finished. So 3b, given that h of x is mapped onto 3x minus 1 all over x plus 5. State the value of x for which h of x is equal to 0. So we know that h of x is equal to 0, and we also know that h of x is equal to 3x minus 1 all over x plus 5. So since h of x is equal to 0 and h of x is also equal to 3x minus 1 all over x plus 5, we can say that 3x minus 1 all over x plus 5 is equal to 0. Now, in order to solve for x, we just need to solve this. So we need to get rid of the fraction. So one way, we can multiply this fraction here by the denominator, which is x plus 5. But if we multiply the left hand side by x plus 5, we also need to multiply the right hand side by x plus 5. Whatever we do to one side, we have to do it to both sides. So here, x plus 5 will cancel out x plus 5. So what we're left back with on the left is 3x minus 1, right? And on the right, 0 times anything gives 0. So we still have 0 here. So now we can solve this. So we need to get rid of this negative 1. One way of getting rid of negative 1 is to add 1 to both sides. So if we add 1 to this side, clearly here you can see that plus 1 minus 1, that's going to give 0. But we also have to add 1 over here as well. So what we have here on the left is actually 3x is equal to 0 plus 1, which is just 1. We need to get x by itself. This x is being multiplied by 3, so we need to do the opposite of multiplying by 3, which is to divide by 3. Remember, whatever you do to one side, you must do it to both. So 3 will cancel out 3 here. So what we left back with is just x is equal to 1/3. Right? And we're finished for this part. Now to part 4 that says take the value of x for which h of x is undefined. Now the first thing you would need to do is to write a statement. And your statement would be h of x is undefined when x plus 5 is equal to 0. Because remember, we cannot divide by 0. So we're trying to find the value of x that will make this denominator become 0. So all we need to do is to take x plus 5 and equate it to 0 and solve. So we want x by itself. What we can do is to subtract 5 from both sides. And clearly here, positive 5 minus 5, that's going to cancel out. What we're left back with is just x. And x is going to equal to 0 minus 5, which is minus 5. Now you can test it for yourself. If you substitute x for minus 5 plus 5, that is going to be 0. So the function is undefined at that point. Alright? Now, still part B of number 3, we are now asked to determine h inverse of x. Now, we know we must write the function in terms of y. So we're going to be y is equal to 3x minus 1 all over x plus 5. Now, at this stage, we know we must interchange x and y. So it's going to be x is equal to 3y minus 1 all over all over y plus 5. At this stage, we're going to transpose for y. So in order to get rid of the denominator, we're going to multiply both sides by y plus 5. So I'm just going to show it on the left. So on the left, I would have x times y plus 5 is going to equal to the numerator here, which is just 3y minus 1, right? Now I need to distribute this x to each term inside of the bracket. So x times y, that's going to give me xy. And x times 5, that's going to give me 5x. Equal to 3y minus 1. So at this stage, I need to group the term with y's on one side of the equation, right? So I already have a y term here on the left. I'm going to write it back, which is xy, which means that I want this 3y over to this side. So how can I make it become 0? On the right hand side, I can subtract 3y from both sides. So if I subtract 3y from this side, I'm just going to left back with minus 1. So let me put back my equal sign here and put minus 1. So that's what I'm going to left back with. And on this side, I'm going to have xy minus 3y over on this side. So because, how can I make it become 0 here? I can subtract 5x from both sides, right? So if I subtract 5x from this side, it's going to become 0 on this side. And over here, I'm going to have minus 5x. Alright? At this stage now, I want y, so I have to factorize. So I have to factor out y. So if I factor out y here, xy divided by y, that's going to leave me with x. And minus 3y divided by y, that's going to leave me with minus 3. And all of this should be equal to minus 1 minus 5x. Now all I need to do is to divide by the bracket here. So if I divide by x minus 3 and I divide both sides by that, on the left I will have 1, y is going to equal to minus 1 minus 5x, all of that divided by x minus 3. And here I just have one final step, which is to replace y with h inverse of x. So therefore, I know that h inverse of x is going to equal to minus 1 minus 5x, all of that over x minus 3. And I'm finished. Now, to the next part of the question, it says, hence, solve the equation 3x minus 1 all over x plus 2 equal 2. So to solve this, let me just rewrite it here. I'm going to rewrite 3x minus 1 all over x plus 2 equal to 2, right? So what they want us to do is to determine the value of x. So I need to get rid of the fraction, which is to multiply both sides by the denominator. So if I multiply both sides by the denominator, on the left, what I'm going to have is 3x minus 1 is equal to 2 times x plus 2. Here, I'm going to apply the distributive property to the right hand side to get rid of the bracket. So what I'm going to have in the bracket is 2 times x, which gives me 2x, and 2 times 2, which gives me a positive 4. And just write back what I have here on the left hand side, which is 3x minus 1. So here, in order to solve for x, I need to group the like terms. So what I actually want this 2x to go over to this side, and I actually want this minus 1 to go over to this side. How can I get this 2x over this side? I can subtract 2x from both sides, right? How can I get this minus 1 over to this side? I am going to add 1 to both sides. So if I subtract 2x from both sides, what I have on the left, it's going to be 3x minus 2x is equal to this 4 that I have. And if I add 1 to both sides, it's going to cancel out on the left, and here I'm going to have plus 1. That's it. So now I just need to simplify the like term. So 3x minus 2x, that leaves me with x. It's going to equal to 4 plus 1, that's going to give me 5. And we're finished there. Now, to our final question for this video, we have if f of x is equal to 3x minus 5 and g of x is equal to half x, calculate the value of f of minus 3. So again, we're substituting minus 3 into the function f of x. Therefore, f of minus 3 is going to equal to 3 times minus 3 minus 5. So 3 times minus 3, that's going to give us minus 9 minus 5. And minus 9 minus 5, that's going to give us minus 14. We're finished it. For the part B(I), we're asked to write an expression for f inverse of x. At this stage, you should be able to look at a function like this and just state the inverse. So it's going to be x. We know at some point we're going to do the opposite of subtracting 5, so it's going to be x plus 5. And we know that we're going to do the opposite of multiplying by 3, which is to actually divide by 3. So therefore, f inverse of x is equal to x plus 5 over 3. And for the last one, we have g inverse of x. You must be able to do this mentally. So this is just going to equal to g inverse of x is going to equal to 2x. That's it. Right? Thank you for watching, and do enjoy the rest of your day.